Welcome to Chapter 8.1, the extra practice. There's some stuff in it is graphing the function. Well, here it is. We'll do it right here. The function f of x equals ax squared. So we're going to do all different functions, graphing quadratic functions, understanding that the parent function is going to be y equals x squared. I think that's that's in the next couple of examples. So we want to talk about the characteristics. It says identify the characteristics of the quadratic function and its graphs. So this is the graph of this equation, this quadratic equation. So something that we should recognize all of a sudden, we should recognize that negative. The negative tells me it's going to open down. And then the a value is 1, so it's going to be very similar to the parent. The b value tells me that it's going to be shifted a little bit along with that c value. So the c, notice it does not, the axis or the vertex does not go through -2, but it is the y-intercept. Notice the point does go through -2. So this will always be the y-intercept. The b is just going to shift the vertex around a little bit. Okay, so the vertex is this point, and then we also have something called the axis of symmetry. And the axis of symmetry divides this parabola in half symmetrically. So this right side is symmetrical to the left side. And we see that with this point right here. We see it with our y-intercept. Notice the symmetrical aspect of that point on the same vertical location. All right, so let's go through some of the answers. So the vertex is going to be 1, -1. We want to look at the increments, make sure that the increments are moving in 1. Each block equals 1, each block equals 1. So we went right 1, down 1, which gives me a vertex. Now the axis of symmetry must be a linear equation. It's going through x at 1, so my equation for the axis of symmetry is x equals 1. X-intercept, it does not. There are no x-intercepts because it doesn't cross the x-axis. Y-intercept, it crosses at the point 0, -2. I like writing coordinates for my x and y-intercepts. You're going to see different situations where they just want the x-intercept, the value, but I find that it doesn't, it's more accurate to give it as a location. The domain, what are my x values? If I listed all of my coordinates, all my solutions, and I looked at all the x values, could I list them? Yeah, the domain is going to be all real numbers. And that is a symbol for, it's a notation for all real numbers. You can write all real numbers, but a double-backed R is a whole lot more efficient. The range, remember our domains are my x values. The range are my y values. So let's look at my y values. I'm looking along the y-axis. So I see that -1 is my highest one, and then everything is going to be less than that. So y is less than or equal to -1. -1 is a solution because we notice it's a solution right here. It's the vertex. Decreasing. When is it decreasing? When you're going left to right. When is the graph decreasing? So we'll erase this just so we can have a little bit more understanding of this. So let's go to the highlighter. So it's increasing as we move left to right here. It is going to be decreasing. Notice the y values, the outputs are decreasing as I move left to right. So this is going to be the increasing part. This is going to be the decreasing part. And where does it exchange? Well, it exchanges at 1. So we're going to say it's decreasing when x is greater than 1, because once it hits 1, it's decreasing. And when is it increasing? Well, it's increasing when x is less than 1. So when x is less than 1, we notice that those values are decreasing. When is it positive? When are my outputs above? When are my outputs? When are my y's positive? Well, this graph is below the x-axis, so it is never positive. When is it negative? Always. All real numbers. Every single x value would produce a output that is negative. And then we talk about our end behaviors. And our end behaviors start with when x moves towards negative infinity. As we go to the left, what are my y's doing? My y values are they're going down, so are going towards negative infinity. All right, we went left. Now let's go to the right. As x moves towards positive infinity, that's to the right, what are my y values doing? They're going down again. So that would be negative infinity also. So as we move left, we go down. As we move right, we go down also. And those are the characteristics. Those are the important things that you need to be able to convey, write, explain, identify. Let's look at this one. Okay, this is a tricky one. This has some tricky aspects. Let's look at the vertex. Vertex is the low point because it opens up. So it's a min value. And our vertex is going to be 0, -2. Axis of symmetry. My axis of symmetry is going to be right here. It goes through that vertex. So my axis of symmetry is going to be x equals -2. So that equation, that linear equation, represents this line. The x-intercept, well, my x-intercept, where it crosses at 0, -2. My vertex is also my x-intercept. My y-intercept is going to be, -2, 0. Did I do that wrong? No, there was no x-intercept. Sorry, that was wrong. My x-intercept is -2, 0. My y-intercept is 0, 4. My domain is going to be all real numbers. My range, well, my range is going to be y is greater than or equal to 0. So notice that that's my lowest y value. My lowest y value is 0. When is it decreasing? It's decreasing this way. So x is less than -2. When is it increasing? When x is greater than -2. When is it positive? Now this is the tricky part. It looks like it's above the x-axis. This point right here is not a positive value. Oh, sorry, my vertex is not. I kept looking at my vertex and going, that doesn't make sense. Sorry, my vertex is not 0, -2. It is -2, 0. I even said my x-intercept is my vertex, and I didn't switch it. Sorry. So when is it positive? Well, at this point, -2, 0, notice my y value is not positive. So it's actually going to be two parts. It's going to be when x is less than -2 or when x is greater than -2. Notice at -2, it is not positive. When is it negative? It's never negative. And let's go through our end behaviors again. As x moves towards negative infinity, what's my y doing? My y is going up. So my y is moving towards positive infinity. As my x moves towards positive infinity, as I move to the right, my y again is moving towards, it's going up. So it's working towards positive infinity. Number 3. My vertex. Here's my vertex. My vertex is 0. We go by increments of 2, so that's -8. It doesn't look like a very good 8. 0, -8. My axis of symmetry is actually going to be right on the y-axis. It's going to be on the y-axis. but that equation is not y. It is x equals 0. X-intercept is going to be 0, -8. Nope, x-intercept. Did I do that? Gosh, yeah. X-intercept, sorry. I'm really struggling. It has been a long day, sorry. Here are my x-intercepts. This is an x-intercept, x-intercept. So my x-intercept is going to be, goes by increments of 2. So that's actually a -4, 0. And my other one is going to be 4, 0. My y-intercept is going to be here, and that is going to be 0, -8. The domain, all real numbers. Range, my y value is going to be greater than or equal to -8, because we're going up. When is it decreasing? When x is less than 0, it's decreasing. When is it increasing? When x is greater than 0. When is it positive? Positive are the two places here. So when x is less than -4, and when x is greater than 4. When it's greater than 4, it's above. When is it below? Since this is a segment, we have to write it as a compound inequality. So it's going to be -4 is less than x, which is less than 4. That's going to be in between here, -4 to 4. My end behaviors, as x moves towards -infinity, my y is moving towards +infinity. As x moves to +infinity, my y is also moving towards +infinity. My infinity signs are pretty lame. All right. I'm making a video. Number 4, my vertex. My vertex is going to be 6, 3. My axis of symmetry is going to be on that vertex. So I know my axis of symmetry is going to be x equals 6. These are always going to be the same. My x value is always going to be my x value in my vertex. My axis of symmetry is always going to be the x value of the vertex. X-intercepts, we're going by increments of 3 now. So I have 3, 0, and 9, 0. My y-intercept, also increments of 3, so that's going to be 0, -9. That's down here. My domain is all real numbers. My range is going to be y is less than or equal to 3. When is it decreasing? When x is greater than 6. When's it increasing? When x is less than 6. It's increasing. When is it positive? This is the segment this time. So that's 3 to 9. So 3 is less than x, which is less than 9. When is it negative? When is it below the x-axis? That's going to be when x is less than 3 or when x is greater than 9. And the end behaviors, as x moves to -infinity, my y moves towards -infinity because it's going down. As I move to the right, my y are still going down. All right, those are 4 really good examples. Hopefully you got those. Now let's move into the graphing parts. Here's our function again. We're going to do all of these equations where you have ax squared. Remember, when a equals 1, that's going to be the parent. When a is greater than 1, it's going to be a stretch. And when a is between 0 and 1, it's going to be a shrink when it's a fraction between 0 and 1. Okay, so those are things that we need to understand. The parent always remember what the parent looks like. The parent equation is 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9, and this is what it looks like. That's the parent equation, y equals x squared. Okay, so when we're working with the parent, that's what all traditional quadratics are based upon. And now we will stretch, shrink, reflect. You'll also translate. You'll have a translation along the y-axis, and then your b that would be your c value, and then your b value will move it across the horizontal axis. So when we do this, we want to know, it says graph the function. Okay, so what we can do is we can plug in values. This is the slow way. This is the snail way. So x, we have, I think it's g of x. We have g of x. G of x equals 7x squared. And then what is our g of x value? And then what is our coordinate? X comma g of x. So we're going to plug in values. 0, 1, negative 1, 2, negative 2. So when we plug in 0, we're squaring 0 and then multiplying by 7, which is 0. So my first point is 0, 0. Then we'll plug in 1. G of 1 equals 7 times 1 squared. 1 squared is 1 times 7 is 7. So we get 1, 7. Plug in negative 1. G of negative 1 equals 7 times the quantity negative 1 squared, which is 1 times 7 is 7. So we get negative 1, 7. Now it's going to start getting big. That's where it's not fun. So G of 2 equals 7 times 2 squared. 2 squared is 4 times 7 is 28. So now we're at 228. We see whenever we deal with exponents, they get exponentially big. They get big exponentially fast. Excuse me. Negative 2, 7 times negative 2 squared. Negative 2 squared is 4 times 7 is 28. And we get negative 228. So when we graph this, it's kind of hard to graph it on a normal graph, but we'll show it. It's 0, 0. It's 1, 7, negative 1, 7. And then we get crazy. Then we get 2, and we get 28. So 2, 28, negative 2. And so here is my graph, what it looks like. So that's why any value greater than 1 is stretching. It stretches this parent. It stretches it way up. So now we're going to, that's the graphing of the function. These are some of the values that we get. And then we're going to compare the graph to the graph of f of x, the parent. So what is the vertical stretch or shrink? It is a, let's move that over. It is a vertical stretch. Let's not put that there. Let's move the parent. Move that. Let's move you over a little bit. There we go. Everybody can be in the same place. So 1, let's deal with 1. Is it a vertical stretch or a vertical shrink? It is a vertical stretch by a factor of 7. So we look at the A value. The A value is 7. So it's a stretch factor of 7. It opens up, or does it reflect over the x-axis? It opens up. What is the vertex? The vertex is 0, 0. And the axis of symmetry is x equals 0. It's right along the y-axis. So when we compare the two graphs, okay, so this new graph has a stretch factor of 7. They both open up. They both have a vertex of 0, and they both have an a axis of symmetry is going to be the same too. Okay, so if we look at that, that's our graph. It's stretched. Notice they went increments of 5. It's a vertical stretch by a factor of 7. Both open up. Both have the same vertex. Both have the same axis of symmetry. So we know that. Good. All right, let's look at this one. So this is a fraction. So h of x equals, technically, that's 1/4 x squared. So if we want to plot those points, you're going to have 0, 0. We're going to plug in 1. 1 squared is 1 times, so that's going to be 1 1/4, negative 1 1/4. So 1's not a great number to do, but it's okay. 2 gives us 1/2. Negative 2 gives us 1/2. Sorry, 2 does not give us that. Sorry. Here I am shortcutting. 2 gives us 1. That makes more sense. 2 gives us 1. 2 squared is 4. And negative 2 gives us 1. Let's do 4. So 4 is 16. Divided by 4 is 4. So 1, 2, 3, 4. 4, you get 4. 1, 2, 3, 4. So we're going to look at the symmetry 4-way. 1, 2, 3, 4-way. So here's my graph. We could do 8. No, that's too much. 8's going to be way out there. So this is the graph of that h function. All right, so it has a vertical shrink because a is between 0 and 1. So it has a vertical shrink. And notice it's shrank down. It squatted down a little bit. A vertical shrink of a factor of 1/4. It still opens up. The vertex is still 0, 0. And the axis of symmetry is x equals 0. Okay, so compared to the parent, there's our graph. Yep, notice we go through the same points. That's 2, 1. Notice we went through 2, 1, etc. It has a vertical shrink factor of 1/4. Both open up. Both have the same vertex, same axis of symmetry. Again, we're comparing it to the parent, and this is the parent, okay, with a vertex of 0, axis of symmetry of x equals 0. Number 3, okay, just because it's a fraction doesn't automatically make it a shrink. It actually is a value. A is actually 3.5. So notice that j sub x equals 3 1/2 x squared. I like leaving it as an improper fraction because I can multiply fractions when I plug it in. So we have 0, 0. Are we going to do 1? Sure, we can do 1, 3.5. You have negative 1, 3.5. Now I'd probably do 2 squared, or 4. So let's do 2. 2 squared is 4, which cancels. So that's 14. So we're already way up there. We're up here, 2, 14, negative 2, 14. And that makes sense. It should be a stretch because the value is greater than 1. So this looks like this on a graph. The vertical stretch by a factor of 7/2. It opens up. It has a vertex of 0, 0. And the axis of symmetry is x equals 0. All right, there we go. Vertical stretch of a factor of 7/2. Both open up, same vertex, same axis of symmetry. Yep. All right, this is our first one where we have a negative value of a. So the negative just reflexes. It reflects over the x-axis. So it just puts all the values down there. So when we plug in values, when you plug in 0, you get 0. But now when we plug in 1 squared, you get negative 5/3. So when you plug in 1, you're getting negative 1 and 2/3. So it's right there. Negative 1 gives us that. I'm not going to do 2, but I will do 3. 3 squared is 9. 9 divided by 3 is 3, so you get negative 15. So 1, 2, 3, negative 15. That's going to be way down here. So if we want to keep it proportional, 1, 2, 3, negative 15 is going to be something like that. And 3 is there. So my graph looks like that. If I need to list values, I can list values, but that negative reflects it. So my vertical, it is a vertical stretch. It's a stretch because it's greater than stretch. I can't spell stretch. Stretch of. Now, we don't include the negative when we talk about the vertical stretch. The negative just reflects it. So a vertical stretch of 5/3, which is 1 2/3. So notice it's greater than 1, so that's why. It actually reflects over the x-axis. We notice this is the x-axis and it flipped over it. 3, the vertex is still 0, 0. Even though we reflected, it's still 0, 0. And the axis of symmetry, is still going to be x equals 0. Vertical stretch, a factor of 5/3. Notice no negative included in there. The negative is represented by the reflection in the x-axis. Same vertex, 0, 0. Same axis of symmetry, x equals 0. Same thing here. We have a negative, and then we have 3/4. So my first point is going to be 0, 0. I plug in 1. I'm going to get negative 3/4. Plug in negative 1. I get 3/4. Plug in 2 is going to give me negative 3. 1, 2, 3. Plug in negative 2. We get negative 3. Let's plug in 4. 4 squared is 16. So we get 1, 2, 3, 4 is negative 12. And 4, that's 2, 3, 4 is going to be that. So this is my graph. I'm picking numbers that are conducive to my getting rid of my denominator. Let's talk about, so it's a vertical shrink. And that's a vertical shrink of a factor of 3/4. And then it's reflected over the x-axis. 3, what's my vertex is 0, 0. And my axis of symmetry is x equals 0. Vertical shrink by a factor of 3/4, reflection over the x-axis, same vertex, same axis of symmetry. This again is still a fraction. N of x equals negative 2/5 x squared. 0.4 is 4 over 10. 4 over 10 can be simplified to 2 over 5. So the negative reflects it, but my vertex is 0, 0. We'll plug in 1. Negative 2/5. That's actually right there. And now I'm not going to do 2. I'll do 5. If we do 5, 5 squared is 25. Divided by 5 is 5. Times negative 2 is negative 10. So 1, 2, 3, 4, 5, 10. And 1, 2, 3, 4, negative 5, 10. So those are my points. If I need more, I can plug in ugly numbers to get fractions, but I'm pretty good at this point. It is a vertical. That number is less, it's between 0 and 1, so it's a vertical shrink of a factor of 2/5. It is reflected over the x-axis, and the vertex is 0, 0, and the axis of symmetry is x equals 0. Vertical shrink by a factor of 0.4, reflection in the x-axis. I'd like over the x-axis. Same vertex, same axis of symmetry. All right, I like these. These are fun. So describe and correct the error in graphing and comparing f of x, which equals that. So we know that that's the parent one. So that is talking about this equation. We can see it for a couple reasons there. And we also see 0, 0, 1, 1, 2, 4. We see those points that we're expecting. And now, what's that one doing? So first of all, it's reflecting, and then it's going to be a stretch. It doesn't look like a stretch, does it? It looks like it's similar. So they didn't stretch the graph of G. The points, let's talk about points that we would expect from x and g of x. So you plug in 0, 0, which is point. Plug in 1, we would expect to get -2. Plug in -1, you expect to get -2. 1 squared times -2 is -2. Plug in 2, you'd expect to get -8. And plug in -2, you'd expect to get -8 again. So when we look at these points, we see 0, 0, okay, that's supposed to be where it is. 1, -2, 1, -2. That graph should be there. -1, -2. So these points are off. When you plugged in 1 in this one, you would expect to get 1. When we plugged in 1, we didn't get -1. So the graph has the same vertex, same axis of symmetry. Those are true. The graph G is a reflection in the x-axis, and the graph of f of x, no. It has to be a vertical. Definitely is reflected over x, but it's a vertical stretch of a factor of 2. So that would be the correct characteristic. Vertical stretch by a factor of 2 was not taken into account. Yep, exactly. All right, the arch support of a bridge can be modeled by, so we have this bridge, and on bridges we have these things, these arches that go underneath it, and it supports it, okay? So that arch support can be modeled by this equation. Now that makes sense because we see the negative, because this arch is upside down, so that's good. And notice my A value. My A value is a big fraction, and that's going to make it super wide. So that makes sense too. Of course it's going to be wide, way, way out there. Where x and y are the measured in feet, the width of the arch is 900 feet. Okay, so that's 900 feet wide. Okay, I don't know what that's sort of, oh, that's 900 feet. So the middle of it would be 450 feet, right? Because that's half of it. So if we draw our axis of symmetry, if the total is 900, so let's go pen. So that's going to be, from here is going to be 900 feet. So half of that, so that's going to be 450, and that's going to be 450, technically -450 from the center. Okay, the width, describe the domain of the function. Okay, because this is not an arrow, there's actually a finite number. So that's interesting. So describe the domain of the function. Are we expecting the axis to be in the middle? I mean, that's kind of interesting. Or is this going to start here? Is this 0 or is this 0? So they don't do a very good job of telling me where the 0 is. Okay, well, if it's 0 to 900, maybe that's where it is. So describe the domain of the function. We'll assume that this is actually, oops, sorry. Because they said it's 900, I'm going to move this over here. Now this is not a dotted line. This is now my y-axis. So I want to, wait, let's do this. We can do this. Sorry. We're going to do this. We'll leave this here, but we'll draw the axes. Okay, and we'll sort of say this too. We'll put it on a graph just to make it a little bit better. And we'll put that there. Okay, so we'll pretend that that's the intersection. This is 0, 0, and this would be 900 all the way out. Okay, but that bridge splits in half of the center. We'll just remember that that's 450 and that's 450. But from 0 is that to 900, so my domain are my x values. So my domain are going to be between 0 and 900. And we're going to equal signs because it's going to start there and it's going to end there. So my domain is going to be between 0 and 900. Describe the domain and explain. Well, those are my x values. Those, if I put out all these dots, I'm going to go from 0 to 900. Use technology to graph the function using the domain in part A. Find the height of the arch. Find the height of the arch. Oh, well, the height of the arch is going to be the middle point, so that's where the 450 comes into play. So my axis of symmetry is going to be at 450, so we put that in there, 450 squared. Oof, okay, so let's do some math. So 450 squared equals that, and then we're going to multiply it by, we're going to divide it by 300. And why would we get a negative value? We wouldn't. Wait, what does it say? What is the height? Let me see. So, all right, we got this. Negative 675. Negative 675. It's not negative. That would be 6. If this is 0, that's 675. So find the height of the arch. Maybe the arch is above it. No, it's... Am I doing the arch upside down? Oh, yeah. No, that's upside down. That's correct. The height of the arch. Oh, well, the height of the arch is 650, right? I think we said 650. What did we say? 675. So the height of the arch, I know what we're going to explain, is 675 feet. Okay? So the reason being, if this is 0, and my high point is 675. So I'm pretty sure I'm correct there. Let's look at the answers. Oh, look at that. Yes. All right. So it did put it in the middle. So 450 feet in both directions. I could argue either one, right? So the vertex is at 0. I had my vertex at 450, and that vertex point is 450, 675. And then that's what the arch looks like, and the height is 675. So I got that part right. All right, so we knew that was going to be an interesting situation, how you perceive where your axis of symmetry is. So I think I did a pretty good job of demonstrating and explaining my answer. A parabola opens down and passes through the points. So opens down is a big hint right there. So let's do this. Passes through the points -3, 4. Let's make those smaller. 1, 2, 3, 1, 2, 3, 4. So we got 1 point. Let's do the other point is 1, -2. Okay. How could you know that -3, 4, the green one, how do you know that that could be the vertex? Well, it could be because it's my highest point. You know what I don't know if that is. It could. That's the important word right there. It could be. It doesn't necessarily. It can keep going and turning, but I know it's opening down. So I know what I do know is that 1, -2 is definitely not my vertex. It could be my vertex if, oh, let's do dotted. And let's do blue. What? That didn't work. Blue. I want dotted. So it could be like this. It could also be this. So there's a whole bunch of stuff. It definitely isn't turning. It hasn't reached its, this is the apex or apex. This is the vertex, or the vertex is further to the left. It will not be to the right. The vertex can be to the right, actually. Sorry. I'll show you an example where it can be to the right of this point. Let's erase one of, no, let's not erase those. Let's turn this a different color. Let's make that red. Oh, sorry. Oh, because I did them together, huh? Oh, this will be interesting. Group. Oh, okay, that's good. That's what I wanted. So let's make this green. That's red. That's situation. And now let's do this. Let's do blue. Thought I did blue. Blue, let's show another situation. The other situation could be where we're on the downslope for that point. So that's another situation where the parabola opens down and the vertex will be to the right of that point. So the vertex will never be to the right of that point. That's for certain. It can be here, it can be the point, or it can be past it. So very important. Hopefully you understood that. Because the parabola opens down the value of y, the vertex is the greatest y value. The y value of the vertex is the greatest value. Yeah, so that's not really a good example. The parabola has the equation f of x equals ax squared. Find the value of a when the graph passes through this. This is a really good question. Students struggled with this. Okay, so we know this is my x and this is my y. So if this is my x and y, so I'm going to put -1, and I'm using this formula. Y equals a, I don't know, and then x is 3, and it's being squared. So I have -1 equals a times 9. We'll divide by 9. And we get -1/9 equals a, if it's going to contain that point. Okay, so find the value of a when it passes through, and a is less than 0. Yep, a is less than 0. It's -1/9. And a is greater than 0. Okay, find the value of a when the graph passes through that. Find the value of a. So this is upside down shrinkage. Find a value of a when a is greater than. All right. So if it opens up, well, let's look at a graph. I want to see it on a graph. So let's graph these. Let's graph it. Whoops. So we have the point. What are the points? 3, -1. So 3, -1. And it is a, so it's going to go through, so we know, and it's going to be upside down. So, I mean, it can go like that. That's not a bad thing. We can do that. That's not impossible. Goes to the origin. So, right, because we know there's no C value, there's no B value. The only thing, so every AX squared is going to have a vertex of 0 and an axis of symmetry through here. So we know that it's going to be symmetrical. So we know that it's going to be here also. And it's just going to be this. I mean, it has to be. So that equation is y equals -1/9 x squared. That's one of the graphs. That's the only graph. That's a graph that contains that point. Can I do the same thing with it opening up? No, I don't think I can. It's the same point. So 1, 2, 3, -1, but it opens up, and all those other characteristics have to hold true. 0, and it has to open up. So hypothetically, I can't contain that point. So I'm going to say it can't happen. Not possible. Let's go. Not possible. Yeah, has a greater than 0. Okay. Got a little nervous. I kind of thought, I didn't. Hey, like I talk, I'm always open to me being wrong. So make sure that when you are doing it, don't be closed to you making a mistake. Take your time, think through it, draw it, do some examples. You saw how I drew it out, and I could now defend my assumption, my hypothesis. Okay? So enjoy. Hopefully this helped.